back. If you noticed from the last video, I'm wearing the same shirt as I wore in that video. Yes, it has been 3 days since I've recorded, but I wanted to keep this shirt on the whole time. So be glad that YouTube does not have a smell feature to it. Anyway, okay, that was lame. I'll try not to use that joke again. But what we're looking at is logarithms today. And the key to understanding logarithms is understand logarithms are exponents. Logarithms are exponents. Now, this year in college algebra, they've kicked out a couple of the sections from logarithms, one of those sections being a section on solving when your base is an exponent. I'll try to show you one problem like that, but you will not be tested on that. But that's the whole reason we have logarithms, because you may think, well, if a logarithm is just an exponent, why don't we just do exponents? Well, because there is a special situation where you need logarithms to be able to handle some different things. Also, on the last lesson, exponentials. We dealt with exponentials. I wasn't clear about the difference in an exponential and a polynomial type equation. The difference is in exponentials, your variable moves up to being the exponent. X squared is not an exponential equation, but 2 to the x is an exponential equation. So, now let's look a little bit at logarithms. Again, I said a logarithm is an exponent. So if you have the log base b of m is n, that implies, again, this is your logarithm. The logarithm is n. The logarithm is n. This is, and it's read log base b. So think about what you do with a base. A base is what you put to the exponent. So this is saying that b to the n power is m. The log base b of m. Let me start back over. The log base b of m is n. So, a few things here. B must be greater than 0, and b cannot equal to 1. And if you think about why that would be true, think about 1 to any power is 1. So, and b has to be greater than 0. M in return has to be greater than 0. And last of all, n can be anything. Because your exponent can be anything. If you think about the last lesson, we took things and raised it to positive numbers. We took things and raised it to negative numbers. We didn't take anything to raise it to a fraction, but let's look at that. If we had 4 to the 1/2 power, again, 1/2 as an exponent just means, hey, we're going to take the square root here. So that's equal to the square root of 4, which is 2. So a fraction as an exponent implies that there's a root involved. Now, let's analyze this a little bit more. Let's say we have the log base 5 of x equals -2. Well, that simply means we are talking about 5 to the -2nd power equals x. All right, and think about the last lesson. -2 as an exponent meant this becomes 1 over 5 squared equals to x. So x would be 1/25. All right. The log base 9 of x equals to 1/2. All right. So this implies that you've got, again, your base to your exponent. So this would be the square root of 9 equals x. So x is going to equal 3. Now, a lot of times we do square roots, we say, hey, we're going to do the plus or minus of the square root. But that's not what's happening here, because you do the plus or minus when you insert a square root into the problem. When we had this 1/2 here, the square root was already inserted into the problem, so there is no plus or minus to go with that. All right, now that's the easiest situation. Um, the next situation's a little bit more involved. So let's go with the log base 10 of 1,000 equals x. Now, 10 is special when it's a base. It's also known as the common logarithm. When you do a logarithm in your calculator, your calculator automatically goes to the common logarithm. So if you do the log of 1,000 in your calculator, it'll get the same thing as you get when you do this problem here. But again, this means 10 to the x equals 1,000. Now, that would happen to be 3. 10 to the third power is what's equal to 1,000. Okay, well here we have a fractional exponent. This would be 10 to the x equals 1 over 1,000. Well, think about how we went. This is a number in the numerator, so how would we go from a numerator to a denominator? And that is, we throw in a negative with that exponent. So x here actually equals to negative 3. All right, the final place that we need to insert a logarithm or a base is a variable. The last place we need to insert a variable is as a base. We have not looked at that yet. All right, the log base b of 16 equals negative 4. Well, and this is a 6 and this is a b. Mine look a little bit alike. So b to the negative 4th equals 16. All right, now, anytime I see negatives in these problems dealing with an exponent, I start working in my mind, a fraction is going to be involved in here somewhere. Now, it may be going from a fraction to a whole number, or it may be going from a whole number to a fraction. In this case, we have b, so we're just going to assume it to be a whole number here. And so we may wind up having to turn this whole number to a fraction. We'll see in just a second. But we got b to the negative 4th is 16. Well, think about what this is. What with 4, all right, 4 squared is 16, but also 2 to the 4th is 16. So I'm going to start messing around with 2 and seeing what I can do with 2. Well, if I do 2 to the negative 4th, that's 1/16, right? But I need 16 over 1. So then I can think, well, okay, well, let's make this 1/2 to the negative 4th. Let's see what happens here if we do this arithmetic. Well, that's the same thing as 2 to the positive 4th, and then there we have it. So b equals 1/2. So that's the first part of this lesson. In a minute, I'll show you some application with exponentials, and I'll show you also about the natural log. That's the other button that's in your calculator, and we'll go from there.